Welcome back to the deep dive. This time we're looking at large language models and robotics, specifically service robotics.
Yeah, it's a really interesting area. We're seeing LLMs like GPT-3.5 and GPT-4 being used to give robots a whole new level of understanding, when it comes to interacting with the real world.
Yeah, you're right. This research from the University of Bonn really caught our attention. It's a far cry from the old way of programming robots for each task.
Absolutely.
They put these LLM-powered robots through their paces in something called RoboCup at home.
It's a really fascinating test bed. RoboCup at home, it's like a virtual obstacle course for robots,
Okay.
mimicking the complexities of a home environment.
So like a kitchen, bedrooms, living rooms.
Exactly. All filled with objects the robot needs to interact with.
That's a great way to assess how well these robots can handle messy situations. And to make things even more challenging, the researchers limited the robot's actions.
Right.
Things like moving to a location, finding an object, grasping it, placing it, and signaling when a task is complete.
Yeah, by doing that, by constraining the robot's physical abilities, the researchers could really focus on the role of the LLM in orchestrating these complex behaviors. It's like figuring out how much you can accomplish with just a few simple tools, right?
And that's where the ingenuity comes in, right?
Yeah.
The researchers designed 4 tasks to test the limits of what these LLMs could achieve. And they weren't random. They were carefully chosen
Exactly.
to represent the kinds of things we'd expect from a helpful service robot.
Right. So it starts with the fetch task, which is all about understanding basic instructions and spatial reasoning.
Okay.
Can the robot interpret a command like, bring me the sponge from the kitchen,
Right.
and navigate to retrieve the object?
It's like a fundamental building block of any service robot, right?
Yeah.
You need to be able to fetch things. But then it gets more complex with the conditional tasks.
Right. This is where you start to see the LLM's ability to handle if-then scenarios, which are really essential for decision-making. In the real world, imagine instructing the robot to check if there's a spoon in the drawer. If so, bring me a pen from the study. Otherwise, bring me a comb from the bedroom.
It requires the robot to not only understand, but assess the situation
Yeah.
and make a choice based on what it finds. This is a level of flexibility we haven't really seen in robots before.
Yeah, that's right. And it highlights the potential of these models
Right.
to bridge the gap between human language and robotic action. But it doesn't stop there.
Oh, there's more.
Yeah. The researchers also included the equals task, which looks at the robot's capacity for numerical reasoning and repetitive actions.
So give us an example of what this equals task looks like.
Okay, imagine you instruct the robot to, for every apple in the bowl, move a fork from the kitchen to the table. The robot needs to understand that numerical relationship, identify the objects, and then do the action the right number of times.
It's like a basic math test, but also shows the LLM's ability to handle things like looping and conditional execution.
Exactly. Now, the final task is where it gets really interesting.
Okay.
The distribute task. This one is all about planning and problem solving.
Sounds like the ultimate test. What does it entail?
So imagine asking the robot to distribute the pens so that each room has at least one.
Yeah.
The robot needs to understand the goal, figure out where the pens are, how many each room needs, and then plan to move the pens around.
That's a lot for a robot. That would take a human some planning.
Yeah, and that's exactly what the researchers were looking at. Can these LLMs give robots that level of complexity, that level of uncertainty?
So we've got these 4 tasks designed to really push these LLMs. But the researchers didn't stop there.
Yeah.
They also wanted to see how different prompt engineering techniques could change the robot's performance.
Yeah, prompt engineering is becoming a really important part of working with LLMs.
Okay.
It's about crafting the right input to get the result you want from the model.
It's like giving the LLM hints on how to approach the problem, almost like whispering in the robot's ear. They tested out a few different techniques, starting with chain of thought.
Right, or COKE.
COTU.
With you're encouraging the LLM to break down its thought process into a step-by-step plan.
Like asking the robot to think out loud before it acts.
Exactly.
Seems very intuitive for us humans. What other techniques did they use?
Well, another one is reasoning and acting, or REACT. This creates a tighter feedback loop
Okay.
between the reasoning and the action. The robot reasons about the task, takes an action, observes the result, and then reasons again.
So the robot is constantly learning and refining its approach.
Yeah,
That
exactly.
seems powerful for handling those unpredictable situations.
Absolutely. They also tried giving the LLM an example of a similar task. This can really help it understand the concept.
like showing the robot a completed puzzle before giving it a new one. Those examples can be so powerful for learning. But they didn't just focus on the high-level reasoning techniques. They also looked at giving the LLM more details about the robot's state and its knowledge of the environment.
Right. They experimented with including a summary of the robot's current state and what it knows in the prompt to make sure the LLM had all the information when making those decisions, especially in those more complex, longer tasks.
Like giving the robot a mental checklist before it starts.
Yeah, exactly.
Making sure it doesn't forget anything along the way. With all these techniques, it must have been fascinating to see how the robots performed.
Oh, it really was. The researchers used GPT-3.5 and GPT-4, and the results show some really interesting things about how capable these LLMs are in a robotic setting.
This is where it gets exciting. We've got the tasks, we've got the prompt engineering tricks, and now we're going to look at the results. But before we do that, let's hear from our sponsors.
Okay, so let's jump into those results. Starting with that basic fetch task. GPT-4 Turbo aced it. Yeah, it got perfect scores no matter what prompting technique they used. Really shows how powerful GPT-4 Turbo is.
So for those simpler tasks, it sounds like a basic prompt is all you need. But what about GPT 3.5 Turbo?
GPT 3.5 Turbo needed a little more help. With just a basic prompt, it didn't do quite as well. But when the researchers added things like chain of thought reasoning or gave a clear example, it got a lot better.
So even a less powerful LLM can do well with the right prompting. Now, the conditional task with the if-then logic seemed trickier. What happened there?
GPT-4 Turbo still did well, but not perfectly. Giving it a clear example was key.
Right.
Once it had that extra context, it got everything right.
So it seems like those examples are a really powerful learning tool, even for these advanced models.
Yeah, definitely.
That you're saying, here's how to solve a similar problem.
Right.
Now use that for this new one. What about GPT 3.5 Turbo?
For GPT 3.5 Turbo, those examples were essential. It really needed them to get a good success rate on that conditional task.
Okay, so it really shows how important those examples can be. Now, things got really interesting with the equals and distribute tasks. Those were the real tests of planning and problem solving. How did the models handle those?
Well, this is where we start to see a real difference between GPT 3.5 and GPT-4. GPT 3.5 Turbo, even with the fancy prompting, had a much lower success rate.
So those more complex tasks really pushed it to its limits. What kind of problems did it run into?
Well, sometimes adding those more complex prompting techniques actually made it worse. It might have been too much information. And that confused the model instead of helping.
It's like giving someone too many instructions.
Right.
It can be counterproductive. But how did GPT-4 Turbo do on these challenges?
GPT-4 Turbo excelled on the equals task, even without the extra prompting. But even GPT-4 Turbo had trouble with the distribute task.
Interesting.
Especially when the researchers used all the prompting techniques.
So even for a powerful model, there's a limit to how much prompting is good. Sometimes less is more.
It seems that way. Plus, those more complex prompts, they take time to process.
Right. Time is important.
Yeah.
Especially in real-world scenarios. A slow robot wouldn't be very useful. Did those detailed state descriptions impact processing time?
Absolutely. Those state descriptions, while helpful, did add to the processing time. So there's a trade-off there between giving the model a lot of information and making sure the robot can act quickly.
It's fascinating. So what's the big takeaway from all of this?
Well, I think it's clear that LLMs have huge potential in robotics. They could help us move away from the old rigid programming and towards a more intuitive way of interacting with robots.
It's like giving them common sense.
Yeah.
The ability to adapt. But it's not a simple solution, is it?
Not at all. We've seen how important prompt engineering is. It's an art to figure out the right way to communicate with the model to guide its behavior.
And choosing the right LLM is crucial too. Like we saw with GPT 3.5 and GPT-4. What else do we need to consider as we go forward?
We have to think about the balance between performance and response time. In the real world, a robot that takes forever to think isn't helpful.
Right. Intelligence versus efficiency. Any other key takeaways?
I think it's important to remember that this research is just the beginning. We're only starting to explore what's possible.
Yeah.
As we move forward, we need to be careful and think about safety, reliability, and the ethical implications of LLMs controlling robots.
It's powerful technology, and we have to use it wisely. Now let's turn to you, our listeners. What are your thoughts on LLMs and robotics? Are you excited? Or maybe a little apprehensive? What really stood out to me was this idea of general-purpose service robots.
Yeah, that's a big one.
A robot that could do all sorts of tasks, even in unpredictable places. It's a pretty amazing idea, but also a little scary.
Oh, definitely. It challenges how we think about robots.
Imagine a robot that could help you clean your house, then turn around and work in a factory,
Right?
or even be a companion for someone elderly. The possibilities seem huge.
They really do. It could change everything about how we live and work. But like the researchers said, there's still a lot to do.
We can't just let these LLM-powered robots loose without being careful.
Right.
We need to make sure they're safe, reliable, and act ethically.
Absolutely.
And we have to understand how those LLMs are making decisions. Transparency is key.
Yeah, we don't want robots making choices we don't get.
It's a conversation we need to have now before this technology gets even more advanced.
Right. We need to be proactive and shape the future of how we interact with robots. And that leads to another big question.
Okay, what's that?
If we can successfully put LLMs into robots, what happens to jobs?
Will robots be our coworkers or our competition? It's something we really need to think about.
It's a tough question with no easy answers. This research gives us a peek into a future where robots aren't just tools anymore.
Right.
They're thinking, adaptable partners. It's exciting and challenging at the same time.
It really is. And it's something we'll keep digging into in future deep dives. Thanks for joining us as we explored LLMs and robotics. We'll see you next time when we take another deep dive into the cutting edge.
Until then, keep asking those questions. Keep learning and keep pushing the boundaries.